Los Angeles is waiting for the wrong disaster. For generations, it has stared east, at the mountains, at the unmistakable scar of the San Andreas Fault. That was the monster. The big one. The one everyone feared. They were looking in the wrong direction. The real threat was never 30 miles away in the desert. It was directly beneath their feet. An invisible fault system terminating just miles below the skyscrapers of downtown. A geological weapon pointed straight at the heart of the city. One that, if it fully ruptures, could generate a magnitude 7.5 earthquake. The result would not be damage. It would be annihilation. Up to 18,000 fatalities. As much as $252 billion in economic losses. The single costliest disaster in American history. And it remained completely undiscovered until a violent shake in 1987 exposed its existence. Now, in 2026, 2 new studies have mapped its behavior and the pressure building around it. And the findings are not just frightening, they are a final warning. Before we chart this invisible map of destruction, one quick question. What part of the city do you live in? Your answer is more relevant to this story than you might think. Let us know in the comments. And if this is the kind of deep dive you need to see, make sure you are subscribed. A huge number of people who watch our videos forget to hit that button, but your subscription is genuinely the only thing that allows us to keep making them. Okay, let's begin. On October 1st, 1987, at 7:42 in the morning, Los Angeles woke up to violence. A magnitude 5.9 earthquake, centered in the Whittier Narrows, shook the region for a terrifying 20 seconds. It wasn't the fabled big one, not even close, but it was different. The shaking felt sharper, more vertical, less of a roll and more of a punch from below. Buildings that had survived other, more distant quakes suffered catastrophic damage. Older brick structures in uptown Whittier crumbled into the streets. A parking garage at California State University, Los Angeles, collapsed. A single Caltrans worker installing a power tower in the San Gabriel Mountains was buried and killed by a triggered rock slide. In total, 8 people died. The financial toll hit $358 million. But the most unsettling discovery was not the damage. It was the cause. Seismologists raced to identify the source, and a disturbing blank space appeared on their maps. The quake hadn't originated on any known documented fault line. It came from somewhere new, somewhere hidden. It took years of painstaking analysis, of poring over seismic data and old oil drilling logs for the truth to surface. The Whittier Narrows event was not an isolated incident. It was a tremor from a much larger, much more dangerous system. A blind-thrust fault. If the San Andreas is a scar on the surface, a blind-thrust fault is an internal injury. It does not break the skin of the earth. The rupture happens entirely underground, on a sloping, angled fault plane. One massive block of the Earth's crust grinds its way up and over another, pushing the land above it upwards with explosive force. This is precisely what makes it so much more dangerous for a city like Los Angeles. The seismic energy is not released dozens of miles away. It is unleashed directly beneath the urban grid, thrusting waves straight up into the foundations of buildings, highways, and utility lines. The Los Angeles basin amplifies this effect catastrophically. The deep, soft sediment that the city is built on acts like a bowl of jelly. When the seismic waves hit it from below, they become trapped. They reverberate, they amplify, they liquefy the very ground a city of millions stands on. This is what happened in 1987. A small segment of this hidden fault had ruptured. It was a preview. A warning shot fired from a weapon nobody knew was loaded. It took another 12 years of scientific detective work before 2 geologists, John H. Shaw and Peter M. Shearer, finally assembled the puzzle. In 1999, they formally identified and named the monster. The Puente Hills Blind-Thrust Fault. It was a 3-part system of interconnected fault segments, running from the northern tip of Orange County, northwest through the San Gabriel Valley, and directly under the dense urban core of Los Angeles. From the working-class neighborhoods of East LA to the financial towers of downtown. It was there the whole time, quietly accumulating stress. Waiting. If you're just now realizing the true scale of this threat, let us know in the comments. We want to know if this is hitting home for you. Once the fault was mapped, the truly terrifying work could begin, modeling its potential. In 2005, the U.S. Geological Survey and the Southern California Earthquake Center, or SEC, ran the numbers. They published a landmark loss estimation study that for the first time calculated the human and economic cost of a full rupture. The figures were so extreme, they seemed to belong to science fiction. A magnitude 7.5 earthquake on the Puente Hills Fault, up to 18,000 dead. That is 6 times the death toll of the 9/11 attacks, up to 735,000 displaced households. A refugee crisis unfolding inside a modern American metropolis, and an economic loss between $82 billion and $252 billion in 2005 dollars. It would be, by a staggering margin, the most expensive disaster in the history of the United States. More than Hurricane Katrina. More than Andrew and Sandy combined. The numbers are so large, they become abstract. So let's make them concrete. $252 billion is more than the entire gross domestic product of Portugal. It is more than the market capitalization of Nike, McDonald's, and Starbucks. Combined, wiped from the balance sheet in less than 2 minutes. And here is the most critical part of the equation. The reason the numbers are so high. A magnitude 7.5 quake on the Puente Hills Fault is significantly smaller than a potential M8. 0 on the San Andreas. An M8.0 releases roughly 16 times more energy, and yet the pit event is projected to be far deadlier. Why? Location, proximity. A smaller gun held directly to the head is infinitely more lethal than a cannon fired from a mile away. The San Andreas lies 30 miles outside of downtown. The Puente Hills Fault lies directly beneath it. The shaking from a peat rupture wouldn't just be strong, it would be inescapable. It would be everywhere, all at once. The north-dipping geometry of the fault acts like a lens, focusing the seismic energy directly into downtown and the LA basin, ensuring maximum destruction. The fault had been identified, the consequences modeled. For years, that terrifying potential sat there. A known variable in an equation with an unknown timeline. A question of when, not if. Then, in June of 2026, the timeline began to sharpen. 2 separate studies, published just days apart, provided the most detailed and disturbing picture of the fault system to date. The monster was not sleeping. For years, mapping the Puente Hills Fault in more detail was a uniquely difficult problem. How do you see something that is, by its very nature, invisible? How do you trace the history of a fault that never breaks the surface, buried beneath one of the most densely developed urban landscapes on the planet? You cannot dig a trench across downtown Los Angeles. You can't visually survey a fault line that runs under Dodger Stadium. You have to use sound. You have to create your own miniature earthquakes. And if you know anyone in Southern California, this is the time to share this video. Hit the like button so this vital information can reach more people who need to see it. It is that important. The techniques are almost crude in their simplicity and brilliant in their application. Scientists with the Southern California Earthquake Center deploy what are essentially truck-mounted mini vibrators. They drive a convoy through the city streets, stopping at precise intervals to press a heavy plate onto the pavement and shake it, sending controlled acoustic waves deep into the earth. For smaller, more sensitive areas, they use sledgehammers, striking steel plates on the ground. These sound waves travel down, bounce off the different layers of rock and sediment, and return to the surface, where they are recorded by a string of listening devices called geophones. It is a city-scale ultrasound. Each echo helps build a 3D image of the geology thousands of feet below ground, revealing the folds, the fractures, the places where the rock has been broken and pushed upwards by the fault. This is the work that has been happening, quietly, on the streets of LA for years. On June 11th, 2026, a new study led by Christoffel J. Anthonissen at Usk, with contributions from original discoverer John H. Shaw, published the results of the most high-resolution mapping effort ever conducted. They didn't just refine the fault's location, they mapped its history. Using a technique called luminescence dating on sediment cores, They were able to determine when different layers of Earth were last exposed to sunlight. This allowed them to calculate how fast the fault has been moving, its slip rate, over the last 1.4 million years. What they found was unsettling. The fault's movement isn't constant. It has gone through periods of acceleration. Specifically, their research shows signs of synchronous acceleration during the late Pleistocene and Holocene epochs. In simple terms, the fault has sped up in our recent geological past. It is not a static feature, it is a dynamic system, and the data suggests it is capable of changing its behavior over time. The study confirmed the PEAT's potential for a magnitude 7.1 to 7.5 event and reaffirmed its status as a major seismic risk in the United States. The invisible enemy was coming into focus. But the picture was about to get much, much worse, because the Puente Hills Fault might not act alone. To understand the second, and arguably more terrifying, discovery of June 2026, we have to look away from Los Angeles. We have to look northeast, to a rugged mountain pass called the Cajon Pass. It is a name that most people outside of Southern California have never heard. But to geologists, it is one of the most critical and dangerous locations in North American seismology. The Cajon Pass is a junction, a choke point. It's the narrow gap between the San Gabriel and San Bernardino Mountains, where two of the most powerful fault lines on the continent converge, the mighty San Andreas Fault and the highly active San Jacinto Fault. For decades, scientists have studied this junction, trying to understand how these two colossal systems interact. Does stress on one transfer to the other? Can an earthquake on the San Andreas trigger a quake on the San Jacinto, or vice versa? The pass is the key, and a new study, published just 8 days before the Puente Hills paper, on June 3, 2026, has provided the clearest answer yet. The answer is yes. A team of researchers led by Dr. Liliane M.L. Burkhardt, a scientist at the University of Bern and the University of Hawaii, did something remarkable. They built a sophisticated computer model of the fault systems around the Cajon Pass. They fed it 1,000 years of simulated earthquake data, a millennium of stress building and releasing. To understand the physics of this crucial intersection, their findings, published in the Journal of Geophysical Research, Solid Earth, introduce a new and chilling concept: the earthquake gate. Dr. Burkhardt's study found that the Cajon Pass can act like a gate, controlling the flow of seismic energy, sometimes, she says, blocking large ruptures from crossing between the faults, and sometimes allowing them to pass through. Imagine a massive earthquake starting far south on the San Andreas. It rips northward at 2 miles per second. When it reaches the Cajon Pass, the gate determines what happens next. If the gate is closed, the quake might stop, its energy confined to the San Andreas Fault alone. But if the gate is open, the rupture can jump. It can leap across the pass and trigger the San Jacinto Fault, creating a cascading multi-fault catastrophe. A megaquake far larger and longer lasting than a rupture on a single fault could ever be. This is the nightmare scenario that seismologists have long worried about. A single event that combines the power of two of California's most dangerous faults. And Dr. Burkhardt's team went one step further. They didn't just model the gate, they measured the pressure on it. Right now. Today. Their model calculated the current stress levels on the fault segments that make up the gate, the Mojave South, the North San Bernardino, and the San Jacinto Bernardino segments. They found the tectonic stress pushing on these faults is now at its highest point in the entire 1,000-year modeled history. The last time a massive quake, the 1857 Fort Tejon earthquake, relieved pressure on this part of the system was over 160 years ago. The stress has been building relentlessly ever since. The numbers are precise. The calculated Coulomb stress levels in 2025 range from 1.8 to 3.6 megapascals, levels that push past historical failure thresholds. Dr. Burkhardt's conclusion is stated in language that is, for a scientific paper, shockingly direct. Right now, she writes, with stress at historically high levels across the region and more than 160 years elapsed since the last major rupture, the system is in a critically loaded state. Critically loaded. That is the language of a bomb technician, not a geologist. It means the system is primed. The gate is not just under pressure. It is under more pressure than at any other time in the last millennium. The conditions are ripe for a rupture to not just happen, but to cascade. So, let's connect the two nightmares. In one corner, you have the Puente Hills Fault, an invisible, city-killing fault directly beneath 10 million people, with a newly confirmed history of accelerated movement. In the other, you have the earthquake gate at Cajon Pass, loaded to the highest stress levels in 1,000 years, primed to allow a rupture to jump between the San Andreas and San Jacinto faults. These are not separate problems. They are part of the same vast, interconnected network of tectonic stress that defines Southern California. A major rupture on the San Andreas, or San Jacinto, that tears through the open gate would send catastrophic seismic waves southward, directly into the LA basin where the Puente Hills Fault lies. It could potentially trigger movement on every smaller fault in the region, including the pit itself. We have a map of the weapon under the city, and we have a reading on the pressure cooker 30 miles away. Both dials are in the red. The science has moved from abstract potential to measured, documented reality. The question is no longer just what if, it's what now. Unlike the water crisis in Las Vegas, there is no engineering solution here. You cannot drill a tunnel to escape a tectonic plate. You cannot build an intake pipe to divert a seismic wave. The problem is the ground itself. The very bedrock upon which one of America's greatest cities was built. The only recourse is preparation, retrofitting, and a brutal, honest assessment of risk. The discoveries of June 2026 force that assessment. They strip away any lingering ambiguity about the nature of the threat. For decades, the public focus was on the distant, visible fault. Now science has drawn a clear, undeniable bullseye directly over the Los Angeles metropolitan area. Seismic building codes in California are some of the most advanced in the world. It is true. Modern skyscrapers are designed to sway, not shatter. But the city is not made of modern skyscrapers. It is a sprawling tapestry of older concrete buildings, soft-story apartment complexes from the 1960s. Brittle infrastructure and a web of water, power, and gas lines that were never designed for the violent upward thrust of a blind thrust rupture. A magnitude 7.5 peat event would overwhelm them. The 2005 shakeout scenario projected that thousands of older buildings would collapse. It projected widespread fires, fueled by thousands of broken gas lines, that fire departments would be unable to reach due to shattered roads and collapsed freeway overpasses. It projected a breakdown of the water system, not just for drinking, but for firefighting, turning manageable fires into uncontrollable conflagrations. And that was before we understood the critically loaded state of the Cajon Pass gate. And I know, this is the second time I'm asking. But it is genuinely that important. If this deep research is something you find valuable, please take 1 second to press the subscribe button. It is the only way we have the resources to fund these reports and bring them straight to you. Your support matters. The uncomfortable truth is that Los Angeles, for all its wealth, fame, and cultural power, is living on borrowed geological time. The 2 June 2026 studies are not a death sentence. They are a diagnosis. They provide the highest resolution picture we have ever had of the forces building beneath Southern California. They give us clarity, and clarity is a formidable tool. It allows for targeted retrofitting of the most vulnerable buildings. It informs more accurate evacuation and emergency response plans. It allows us to stop fearing the wrong monster and finally focus on the one that matters. The pit has an estimated recurrence interval of about 3,000 years for a major rupture. It's a number that feels comfortingly long. But recurrence interval is a geological average, not a guarantee. The fault is not on a schedule. The Holocene slip rate variations shown in the new research prove that it is complex and unpredictable. The pressure can build for millennia and release in 2 minutes. The last major quake on this section of the San Andreas was in 1857. The last warning shot from the PT was in 1987. The stress has been accumulating ever since. The story of the Puente Hills Fault is not a story about the end of the world. It's a story about risk, sight, and the slow, relentless work of science to illuminate threats that hide in plain sight, or in this case, just below it. The map is drawn now. The pressure gauges are being read. The uncomfortable knowledge of what lies beneath is no longer in the realm of theory. It is a feature of the landscape. As real as the Hollywood sign, as tangible as the traffic on the 405. The only difference is, you can't see it. But it is there.